we're going to go on and get started. Are there any questions over any of the assignments thus far? Okay. If there are no questions, we're going to start on the last part of Chapter 8. This is the last part of Chapter 8 that we're going to cover, and actually that's in the book. Hey, before you start, I don't want to hear it. Oh, the pin thing? Yeah. Can you tell us what that is? We can figure it out. It's probably due to lift, would be my best guess, that the rotational force of it going around is causing that the air, it's either the air above it is at a lower density than the air below it, so it's causing it to rise, just like with going over the wing of a plane, because if the speed of the air, because it's always trying to keep this right, I think it's if it's going faster below it, it makes the density above it lighter, which causes the wing to go up. So if you achieve that with any kind of speed, it'll do the same thing. So I think essentially you're just achieving lift with that. Because again, it had to get to a certain speed before it would actually do it. Because that's also why planes have to travel at a certain speed to actually maintain or get lift. All right. Triangle proportionality theorem. And what we're doing today with this triangle proportionality theorem, and we start solving, really isn't going to be any different from what we've been doing when solving. And we'll see that here in a minute. Now, this theorem states if a line is parallel to one side of a triangle, these two lines here are parallel, then the intersecting, then it divides the two sides proportionally. So A, B, C, D. Since these two lines are parallel, it's telling us that A over B is going to be at the same proportion as C over D. These sides are going to be proportional. Because for those two lines to be parallel, distances have to be the same. They have to be at the same amount. Now the inverse is true as well. A, B, C, D. If A over B is equal to or proportional to C over D, it means that these two lines here have to be parallel. And that's all this theorem is saying. Any questions on this here? Okay, well, if we look at this first example problem here, in the diagram, QS and UT are parallel. So that means our side lengths are going to be proportional. Yes, sir. Those there are the theorems for Chapter 8. So they go just 1 through however many. So at this point here, these would be the 6th and 7th theorem we've covered for Chapter 8. Yeah, because for most of the chapters, we haven't covered a single theorem a chapter. We've covered more than one. Does that kind of make sense? Yeah, they're just denoting it as Chapter 8's kind of 6th theorem in the overall section. Okay. Now, if we look at this here, since these two lines are parallel, the sides, the corresponding sides, are going to be proportional. So, okay, so we'll have two sides are proportional, and we can use that to find the value of x. Well, they tell us that RS is 6, ST, well, ST is 6, RS is 4, and QU is 9. And we want to find the value of x. So x corresponding side would be what? Corresponding side for x would be 9. Guys. Corresponding side for x would be 9. Now other sets of corresponding sides would be 4 over 6. Any questions on how we set this up? Now, does this look similar to the way we were solving the ones before? So what would we do next? Multiply both sides by 9. And the reason we're multiplying both sides by 9 is because on the left-hand side, if we do the multiplication, actually work it out, we would say 9 times x. And it's being divided by 9. Well, anything divided by itself is 1. So our 9 divided by 9 would reduce to 1. Apparently, I'm just going to continue to erase. Here, the 9 divided by 9 would reduce to 1, giving us just x. Now, on the other side, we can do the multiplication just like we did and say 9 times 4, which is 36, and that there's going to be divided by 6. 36 divided by 6 is 6. So the value of x is 6. And that's it. So we're solving and doing the steps and setting up the way we've done the ones before. We're just using it with a different theorem. Any other questions on this here? 9 times 4. Because we multiply with the numerators. Now, what we could have also done is just typed that entire thing as it is right there into the calculator, and it would have done it for us. Any other questions on this here? Let's look at the next one here. So this one here, we're trying to find the length of zy. I'm just going to call it x because that's what we're used to calling the missing term or value that we're looking for. So how would we set this up? So x over either, let's see, because we're wanting to say 35 and some are wanting to say 36, yes? So let's see what happens. So if we did x over 35, would be what over what? 36 over 44, yes? Now for this one here, we would multiply both sides by 35. And the 35 and 35 would cancel. And now we just need to calculate 36 times 35 over 44. Numerator one more time. 315. Okay. So that's what we get for that value of x. So we know that that is a method that works if the other one does too. Now for the other one, x over 36 would be 35 over 44, yes? Now what are we going to multiply both sides by? Well, here the 36 and 36 will cancel, yes? 315 over. And when we multiply a whole number and a fraction, the whole number multiplies by the numerator at the top of the fraction, yes? So for the first one we did, we multiplied both sides by 36. Really, the first thing we did was multiply the 36 and 35 and then divide by 44, yes? In the other one, when we multiplied both sides by 36 for this fraction, what are we multiplying on the top? 35. We're multiplying still the same two numbers and dividing by 44. But in either case, we set these proportional, because again, the side lengths are going to be proportional, or we set these. Either way, they're still proportional, as long as we don't get them flipped. Make sense? Any questions on any of this here? Wanting to find the length of VW. So how can we set this up? X over 10 equals 12 over 8. Or we could say x over 12 equals 10 over 8. Now what do we do next? Multiply both sides by 10. Because here the 10 and 10 would minus x is equal to 15. And that's a value that makes sense. And the reason I say that is because if we look at the two other values that they gave us, 10 and 8, so if we're going from 8 to 10, is the number getting smaller or bigger? Bigger. 8 to 10 is bigger, yes? So from 12 to x, we should expect the number to get, so is 15 a number that seems right? Yeah, because it got bigger. Questions on this here? Yes, sir. Since we did x over 10, we'll do 12 over 8. Does that make sense? Okay. Any other questions? Okay. This here is doing the converse. Because our theorem that we used for the last two, if the side lengths are proportional, if the lines are parallel, then the side lengths are proportional. We have that proportionality. Now, if the side lengths are proportional, then those two sides, or those two lines, have to be parallel. And that's what it's asking. On the shoe rack, if BA is 33, BC is 27, CD is 44, and DE is 25, explain why the shelf is not parallel to the floor. So we want to know why it's not parallel to the floor. Well, we need these side lengths to be proportional. We need them to have the same proportion. So we're saying that 27 over what? 33 needs to be the same proportion as 44 over 25. Well, 27 over 33 will reduce by a factor of 3, which then give us 9 over 11. How about 44 over 25? Gives you the same thing. So, well, these here, they're not proportional. So why are the shelves not parallel to the floor? The segments are not proportional. Yeah, because I mean, some shoe shelves are on a slant, because it is nicer, especially if they have heels of any kind they can hold on. Yes. Because two reasons. One, it won't be there if it's connected to a smart board. It's not a smart board. The other option is that we have the licensure for it, licensure for the software. Well, we have the money for it. It's just, again, the first option is it's hooked to a smart board, which until this semester it's been hooked to a smart board, so it's not been used. So we switched over. To get the software, they do it at the start of the calendar year, which the calendar year for schools is not in January, it's in June. So we can't necessarily buy the program till June. And the reason it's been not there for quite a while since we got it is I've gotten them to work it so that I can get a demo trial for it until we can actually buy the software. But apparently there's been a change in the program for them to be able to do that, so they can't do it at the moment. They're trying things, so until then, I'm stuck with the watermark. So, yeah. It'd been nice if they could have prorated us the stuff, essentially given it to us now and charged us once it officially becomes June, but not much we can do, because it is annoying that it's sitting there. Yeah, you're good. Okay, this time, well, explain why. Well, know why, because the side lengths are going to be proportional, yes? But it's good to show it, because that's really part of the proof here. Now, there we go. Okay, it would be. There we go. So we look at this here. Now, so AB or BA is 35. CB is 25. CD is 20, and DE is 28. So we have these sides set up, yes? So if we look at it, so 25 on top over is one of our proportions. The other is 20 over 28. So 25 and 35 have a common factor of 5, which reduced to 5 over 7. 20 over 28, well, they both have a common factor of 4, which would reduce to 5 over 7. The sides are proportional. So from here, we're also going from smaller to bigger, smaller to bigger, yes, with how they set up. If we look at the previous one, here we're going from smaller to bigger, and here we're going from bigger to smaller. So most likely it's not going to be parallel, because we need the proportions to be the same. Any other questions on this here? So we do have 2 theorems left. This is one of them, and it's the 3 parallel line theorem. If 3 parallel lines are cut by a transversal, then the sides are proportional. So our AB, CD. So again, AB is equal to C over D. Again, different theorem, but same property is still holding true. So if we look at this here, so Main Street, 1, 2, and 3, these angles are congruent, which is just telling us that these 3 streets are going to be parallel to each other. Now we know that this length is 150, and this one is 300. We also know that this length is 120, and this is x. Exactly. Now how did you get to 240? Yeah. So from 150 to 300, well, we're multiplying by 2, yes? So if the sides stay proportional, that means the scale from here to here should also be multiplied by 2. So we can go from 120 to 240. Now, if we worked it out the other way, 2 fractions, here we're going to have x. And it's going to be over what? 120. And on the other side, we're going to have almost 300 over 150, yes? Now, what would we do next? Multiply both sides by 120. And we do this so that the 120 and 120 will cancel out. Now, at this point, we can type the whole thing into the calculator to get our answer. But before we do that, I mean, you can go on and do that. Here we have 300 over 150. What's that simplify to? 2 over 1. So this really reduces to 2 times 120, which is? Yeah. Because again, that other fraction's always been the scale of how we're scaling it up or scaling it down. Questions on this here? Do we need to see another example of one of these? Do you all feel comfortable with these? Yes? So we can move on. Before we do, because let's see here, 2/5, this here, df, if y'all want to go back and look at it, would be 14. We agree?
Yes.
Awesome. And see it? Yeah. And this is going to work out the same. This one, unfortunately, won't give us a nice whole number. It'll give us a decimal answer. And I can't remember what the whole number answer is, but I know it's going to be 0.2. I think it's 18 or 19.2 if we were to work this one out. Yep. It'd be 19.2 if we work this one out. We're going to move on to the last theorem for this chapter, and that is the angle bisector theorem. If a ray bisects an angle of a triangle, then it divides the opposite sides into segments whose lengths are proportional to the lengths of the other two sides. So what we're saying is here, well, I'm going to call that A. So we can call this X, Y, W, Z. So what we're saying here is that X over Y, the two sides, so the side that's cut in half, those two are going to be proportional to the two sides that connect to it. So it's going to be W over Z. X on top, W is going to be on top. Y is on bottom, Z is going to be on bottom. So they kind of work in those L shapes for the proportionality. So we're finding the value of X. Ignoring that. So we're going to set up our proportionality. And it's always nice to have the variable on top. If I can keep it purely on top, I'm going to keep it purely on top. Now, the side that is proportional to it is our 13. So we're going to have X over 13. Now, the side that connects to X is the length for QR. Do I know what that is? Right, we know that the other length is 9.75. But I do know that the whole length is 15. So what we can do is take 15 minus 9.75. 5.25 would give us our other measure. Because to go from 9.75 to 15, yep, the quarter gives us 10, and then we have 5. Now what do we need to do next? Multiply both sides by 13. Here the 13 and 13 would cancel. Now this looks like it's going to give us an ugly number, but it doesn't. It gives us 7. It's kind of nice when when it works out to be a nice number. Any questions on this here? Oh, yes. So for this one here, we had to find this value of 5.25 to be able to finish the problem out, because that's the only real thing that we needed. Any other questions on this here? Let's look at the next one. We ready? So if we look at this one here, again, we'll have our two proportions, and it's good to have the variable in the numerator. So we would have y over what? Equals 63 over 42. Yeah, no, the new screen can contribute to kind of a finger point and the pointer. And if I have it too far to the side, it thinks its thickness is wider. Now, what would we do next? We multiply both sides by 18, telling us y is 27. That's it. This chapter is kind of nice because even though we have a whole bunch of theorems, we essentially are doing the exact same thing every single time. All right. You got to grab a pass.
Okay, I'll grab a pass. Because Kate's going to be a dumb butt.
So here, we'll have x over what? 14 and 48 over 24. Yes, and then we would multiply each side by 14. These will cancel, telling us x is you switch the 14 and 48? 24 and 48. Yes, and I think it gave you a different answer. So that's a good thing to look at. So we have 7 here, yes? And if we look at the numbers, so 14 to 24, 7 to 48, because 7 to 48 is a massive jump, yes? And most of the time, again, we're staying proportional. A lot of the sides stay proportional in how they look. Here, 27 to 63, 18 to 42. And if we look at 18 over 42 or 27 over 63, that proportion should still be the same, as well as kind of looking at 18 to 27 and 42 to 63. If we look with 7, okay, 7 to 14 gives us a scale of 2, multiplying by 2, and 28 to 24, well, that's going the wrong way. So we would need this to be bigger, so it works out to be 28. I have a feeling as soon as you saw 7, you knew something wasn't right. Okay, last one on y'all's note sheet is this one here, yes? Can anybody take a guess before doing anything of what y is going to be?
Yeah, that.
And if we look at this, so we could say y over 4 square root of 2 is equal to 4 over 4. Which we can multiply both sides by 4 square root of 2. These will cancel. It'll just tell us y is. We get this here. Any questions on this here? Are you ready for the next one? Yeah. There is one more I want to look at. Now this one here, if you do notice, is the exact same as the problem we've already done. Yes? Because the one that we had 9.75. So we do know what x is for this here. So this one here is not necessarily on the notes. But again, it's a good one to look at because it is changed in a little way. Now, here, we are given the length of RS. It is, well, I mean, in the other problem, we did solve for it and found out that it's 9.75, and we will get there. But we know it's x. Now, the side that corresponds to it is our QR. Well, do we know what it is? No, but I do know the whole length is. So this length here is going to be 15 minus whatever that value of x is. Because in the main problem that we did, we took the 9.75 and subtracted it from 15 to get that value. But here, since we I mean, we know what it is. We're going to assume that we don't. We can set it up as this here, 15 minus x, because that's what this length would be, yes? Now, the other side is given to us. Since we put x on top, 13 has to go on top, and it's going to be over 7. Well, so what we're going to do next is not a race. It's called, I think, the butterfly method. Yeah, doing this here, this cross multiply. Because I think Miss Williams might have called it the butterfly method, or Miss Kendall. Or what we're really doing is multiplying here both sides by 7, and the 7 and 7 will cancel out. Now, I also need to multiply both sides by 15 minus x. Because when I do that here, these two will cancel out. That's what that method is, essentially, for us to cancel out the denominators. Now, what that leaves us with is 7x is equal to 13 times 15 minus x. Here, guys, yeah, it does not like me right now. Now, we can distribute the 13. Now, 13 times 15 is, one of y'all help me out, 195 minus 13x. Now, to get all the variables on the same side, we would add 13x to both sides. This will tell us that 20x is equal to, and last but not least, if I divide both sides by 20, which we already knew it was going to be. But that's how we would work this out. Even if we're not given the other side length, given them individually, we're given one whole. But on a whole, is this any harder than what we've been doing? No. Once we notice the trick of how to figure out what this other length is and do the multiplication, it made it a lot easier. We ready for the next one?